Numerical study on seismic behavior of stiffened steel plate shear wall. Any structure can be analyzed for vertical downward gravity load due to imposed and service load as well as lateral load due to earthquake and wind load. In the last 4 decades, attention has been paid to steel plate shear walls, SPSW, as means of resisting earthquake and wind forces in buildings, and especially in high-rise buildings. Aim of this work to study the influence of regularly planed steel plate and to adding various pattern of channel-shaped stiffeners on the seismic behavior of steel plate shear walls, SPSWs. This dissertation aims at developing an understanding of dynamic analysis and response spectrum solution for structural process plant building having steel plate shear wall indifferent for condition 1, plain steel plate shear wall 2, diagonally stiffened steel plate shear wall 3, horizontally stiffened steel plate shear wall 4, vertically stiffened steel plate shear wall. Process plant structure, are important for the continuous operation of any industrial process system in event of earthquakes. The analytical results show that the stiffened steel plate shear wall deformation rotation and lesser developed yield stress compared to plain steel plate. The main object of this paper is, 1. To study behavior of the structure to provided plain steel plate shear wall, SPSW, under the action of lateral load due to seismic load on structure. 2. To study behavior of SPSW with different method of placements of stiffener that is horizontal, vertically and diagonal. 3. To compare the analysis result of SPSW with conventional bracing system in economical point of view. Keywords, shear walls, stiffener, response spectrum. Introduction. A steel plate shear wall, SPSW, system is a type of lateral force resistant structure that comprises infill plates and boundary elements. SPSWs provide quick installation and it is easy to standardize production. 5-story industrial structure was a diagonally, horizontal, vertical channel stiffened SPSW. In this project, the structural model is done in STA8 Pro software. The study parameter are maximum displacement of structure, torsion or rotation, max shear, max bending moment and von Mises stresses in plate and base shear and study the stiffening pattern for lateral resistance of seismic forces. Aim and objective. Aim and objectives of study behavior of the structure to provided plain steel shear wall SPSW under the action of lateral load due to seismic load on structure and compare the analysis result of SPSW with conventional bracing system. Study behavior of SPSW with different method of placements of stiffener that is horizontal, vertically and diagonally. Be need of the work. It will help structural designer in future to provide more options other than traditionally used structural member bracing, plain SPSW etc. For high seismivity zone and industrial structure SPSW to control displacement and to provide great shear strength and ductility to structure subjected to lateral load as well as to provide economical solution. Due to improve aesthetic appearance of structure. 2 problem statement. A general analysis design of 6-story industrial process plant instant connect software, whose major equipment are rest on first floor and minor equipment are rest on particular floor as shown in various floor plans. In this paper. To study behavior of SPSW with different method of placements of stiffener that is horizontal, vertically and diagonal. Elevation of structure is shown in figure 2. D. Analysis. Industrial distillation plant structure is structural steel frame is of 19 m x 18 m rectangular dimension. Structure is ground plus 6-story and depth of foundation is 2.5 m below floor finish level. Structure is modeled instant connect 2018 and analysis and design is done considering earthquake. Earthquake analysis is done by response spectrum method. 6 different model are proposed for analysis and study. Dead, live and equipment load calculations and apply on structure. Design data, steel grade, Fe 500, structural steel Fe 250, soil strata, medium, density of structural steel, 78.5 knots per cubic meter, live load, 3 or 2.5 knots per square meter, height of process plant 34.5 m, above ground level, and founding depth is 2.5 m, below ground level, floor interval 4.5 m each and SPSW thickness, 4 mm. Wind load data, as per considered location and as per IS 875, Part 3, design wind pressure PZ equals 1.0 kN/m2. Seismic load data, seismic load as per IS 1893-2002 Part 1 and Part 4 and parameter considered. Use response spectrum method for analysis. Nodes are very closely than CSM method is use. The structure was excited by response spectrum in X direction and Z direction. As per IS 1893 response spectrum is used otherwise the real data. For conclusion. Based on the results and discussion following conclusions are drawn. 1. Displacement and tensional in conventional brace system is greater than other SPSW system. In SPA system, vertical and diagonal pattern system displacement is greater than horizontal. SPSW system tensional effect is nearly same to all cases. Base shear resistance of conventional system is lesser than all SPSW system, and in SPSW system diagonal system base shear and pick story shear carrying is quite higher than other SPSW system. Due to diagonal stiffener, shear stress is increased in plate, and horizontal stiffener pattern is less. Shear stress is observed as well as in vertical and plane geometry, hence diagonal brace system. Bending moment and von Mises stress greater developed in diagonal SPSW system compared to other SPSW system, and in horizontal stiffener pattern system is lesser than all other SPSW system. SPSW stiffened system is economical than conventional bracing system, and utilization ration of structural member in SPSW stiffened system is lesser than conventional bracing system. As per above result and discussion, SPSW system is good result than conventional bracing system. Scope of future work. From the results of this study, following can be the future scope. Existing plant structure is selected. Seismic zone is in third zone due to existing plant structure is selected, and comparing the conventional and SPSW stiffening system in economy point of view. It is necessary to further analyze and study the structure for high seismic zone for better clarity and result for comparison of SPSW pattern system. In SPSW system, there is another scope is different shape of stiffener and different materials property used, and further analyzes and study as well as changing position of shear wall and study.